Hi everyone, this video is going to be about multi-layer switches, also known as layer 3 switches. So layer 3 switch is just the result of taking a router and a layer 2 switch and combining the two, so you have the best of both worlds. Now layer 3 switch can do about 95% of what a router can do. There's going to be certain situations where you have to have a router. One of the situations is if you want to run BGP and download the routing table for the entire internet, you'll need to have a router because routers are optimized for that sort of thing, whereas switches are not. But a layer 3 switch can do about 95% of it. And obviously, being a switch, it can do 100% of what switching can do. Now, layer 3 switches are the mainstay of networking world. You'll be working with those a lot. They are more expensive than a layer 2 switch, but that's basically because of licensing. Now, do you need to have a layer 3 switch everywhere you go? No, you do not. Is the cost difference enough to make it so that way you want to buy layer 2 switches for the access layer, then layer 3 switches for the distribution layer? It's not that much more expensive, but personally, I like to have layer 3 switches everywhere. That way I can manage things better. I don't have to worry about having to go through and license anything if I run across anything that's a special need. But for the most part, layer 2 switches work just fine, but layer 3 switches, I believe, are where it's at. All right, let's get started. So I have everything set up with the exception of the layer 3 switch. So if we show run, you'll see I just have a bunch of loopbacks. My interfaces are connected in OSPF. Come to this switch over here. I have my trunk set up, the VLAN, native VLAN 100. I just have a couple access ports, nothing configured on them. I have my three VLANs, 10, 20, and 100 as my native. This switch, same thing. I have a trunk with a native VLAN of 200. I have my different VLANs on my access ports. And here's my VLANs. I have IP addresses on all my computers. I have my sales, HR, IT, and another sales. Then I also have my router. So I have a loopback. I have some sub-interfaces, so we're doing router on a stick, basically. And then I have OSPF. And I need to add something to OSPF. And I need to put in passive for there. All right. Now let's go ahead and get started on my layer 3 switch. So this is layer 3 switch. If we just do a show run, you'll see there's no configuration on it whatsoever. So you can start anywhere you want to. Normally, I start by enable routing because that's the one command I always forget. You want to do IP routing. So if you do IP ROUT and hit tab, nothing happens. Question mark, you'll see there's two commands, IP route and IP routing. Make sure you type in routing. What that does is that will enable layer 3 functionality on your switch. By default, layer 3 switches are layer 2. So now that we have layer 3 enabled, we can create SVIs, switch virtual interfaces, that act as the gateways for VLANs. And think of them as kind of virtual sub-interfaces. They are not reliant on anything physical. They're all virtual, so that way you can assign them to any port you want. Now I'm going to go ahead and create some VLANs. So the thing with VLANs is you have to create a layer 2 path to all layer 3 things. And so we are going to have, on this layer 3 switch, VLANs 10 and 30 land and have the layer 3 switch be its gateway. But VLAN 20, we're going to have router 2 be the gateway. And do we have to do that? No. but I just want to show you what the possibilities are with layer 3 switches. And we also have to create all of our native VLANs. Oops, if I can spell. I believe it was 99. All right. So still nothing's configured. We have our VLANs sitting here. Now we can reuse the IDs. We can use native VLAN on every single connection. It does not matter. I just want to show that you can have different native VLANs for each interface and everything will still work. But you can use the same native VLAN if you want to. All right, now let's go ahead and create the SVIs. So that way I can have the SVIs and make sure my layer 2 works to the IT and sales VLANs. And then I'll configure OSPF in my connection to router 2. So to create an SVI, it's very simple. Int for interface, VLAN, then the VLAN ID that you want. You'll see that it came up. And if you do a show run, you'll see it's now right here. I just need to put an IP address in there. And that is done. I always toss in a no shutdown just to make sure, because you can never be too sure, because you don't want to be doing any troubleshooting just to see it that is the issue. It's very infuriating. Now we want to do a VLAN 30 as well. So we'll see I have my VLAN 10 and my VLAN 30. Now we can toss in another VLAN for your management VLAN if you want to, but you can also use any one of these as your management VLAN. And you can also toss in a loopback interface and use that as your management VLAN if you really want to. All right, so I have my SVIs set up. I have my layer 2 routing. So my layer 2 is just VLANs. So this is on my layer 2 parts. Then my SVIs are my layer 3. Now I have to match the VLAN ID with my SVI ID. So 10 has to match 10. If we don't have a VLAN 10, it's not going to work. So now I'm going to configure my interfaces to my switches. Now it's giving me a bunch of errors saying mismatch, native VLAN mismatch discovered on the 2 interfaces. That's because these 2 switches are already configured. Now, the difference between a layer 3 switch and a layer 2 switch is we have to use the encapsulation command like you do on a sub interface for a router. But it's a little bit different. Switch port trunk encapsulation .1q, and you do not have to specify what VLAN to go to. Now switch port trunk native VLAN 100. And then if I want to, I can go ahead and specify I only want to allow certain VLANs across. Switch port trunk allowed VLANs, this is 10, 20, and 100. So what that does is I'm specifying the protocol .1q. I'm only allowing these VLANs across. I'm specifying this as my native VLAN. So this is just called pruning. So you're just pruning the VLANs off of the trunk. So let's configure the next one. Let me just show you what happens when you don't put the encapsulation command in there first. Now this is just saying that I cannot configure it as a trunk unless I set the encapsulation as whatever protocol I want to use. So let's do that. .q, switch port mode trunk, and I forgot I did not do it on the last one. And we're not going to prune it this time. And this one will be 200. Now the reason why I like to do switch port mode trunk is you hard code it to be a trunk. That way no matter what, it's going to be a trunk. And that way, negotiations between devices are usually not good unless it's more of a protocol sort of thing. But for your interfaces, you want it to be hard-coded to be, yes, this will always be a trunk. You never want it to have a possibility of one day it's going to negotiate to be an access port and then cut off all other VLANs. So I have my trunk set up, second trunk set up. I'm only pruning on these ones. And on this one right here, I'm allowing everything across, so all VLANs are across. And I have my 10 and 30. Now let's see if I can't ping it. Let's see if I can't ping the end stations. And I can. Let's try the next one. And I can. Sweet. So what we can do right now is from here, this layer 3 switch, we can ping all the way to sales 1. We can ping all the way to IT. We can ping all the way to sales 2. So let's try that. Perfect. So VLANs 10 and 30 work just fine. So my layer 2 part is done. So all these computers, with the exception of HR, are using the layer 3 switch as its gateway. So that works. Now let's go and configure our connection to router 2. So router 2 is also going to be a trunk. So I set my native VLAN. I can also prune it if I want to. So that way we just only allow VLAN 20. And I always allow the native VLAN just to make sure that it goes across. And now let's see if I can ping from HR all the way across. And I can. So now from the HR PC, I can go across here, a layer 2 path through the multi-layer switch, and router 2 is my gateway. So for sales and IT, the layer 3 switch is my gateway. For HR, router 2 is my gateway, and the layer 3 switch is acting as a layer 2 switch for that VLAN. So I have sort of a router on a stick for that one VLAN. Now let's go ahead and configure a routed port for this connection. So a routed port means an IP address on the actual physical interface. So for the router on stick, we use the trunk, but for routed port, IP address on the interface. The first thing we have to do is we have to disable the port to act like a switch, so no switch port. That will enable the port to act as a physical layer 3 port, where we can put the IP address on it. So I have the IP address on it. Let's see if I can ping the other side. All right, ping the other side. All right, so now I have the router port configured. I can ping router 1. Now I'm going to go ahead and set up so router 2 can ping. So show run. I have my trunks to the switches. I have my IP address for going to router 1. I have my native VLAN over there. Nope, I noticed a mistake. This right here should not be 99. I think if I have this right. Let's see what this is set up as. 88 is my native VLAN. So int gig 02. Let's see how that looks. That looks better. All right, cool. Now, I need to set up my point-to-point connection between the layer 3 switch and router 2. To do that, I have to create an SVI because I already have a trunk going across layer 2. So in router 2, I have it as VLAN 99. So create my SVI into VLAN 99, then my IP address, whoops, there we go, shut, exit, VLAN 99, name, point to point, and just in case I forgot to do it, 88, name, native, let's name it native, point to point. All right. So now what do we have? Our trunks, our point-to-point connection, then our trunk to router 2. I need to add VLAN 99 to that. And I can add it by using the add command. If I do a question mark, you'll see you can add a VLAN. You can just say all for everything. You can say except for these ones, remove them. But I just like to do add. Now the reason why I like to have the list be all the VLANs that are allowed is because it's easier to see and easier to understand. These are the ones that are allowed versus here's the VLANs that are not allowed. We can do it either way. All right, that's what we got now. I'm now allowing all 3 across. That's great. I might VLAN 10, then 30, and VLAN 99. All right, let's see if we can't ping .9. All right, so I verified I can ping workstations. I verified I can ping router 1, router 2. Now I just need to set up OSPF. Router, OSPF, router ID. Let's just go ahead and toss in 7.77. Passive interface, default. Now the reason why passive interface is great is because if we do a do show run, we will see we have a ton of different interfaces and a ton of SVIs. Now this switch only has 24 ports plus 2 gig uplinks. Now imagine a switch that has 500 ports. That's a lot of security holes there, so we don't want that. So now we want to know passive the VLANs, the SVI, VLAN 99, no passive gig 01, and let's see what we got here. Do show run. And now we need to add our network commands. Network 172.16.10.0 area 0 network 30 oops and last but not least there. So now let's see if we're going to have any sort of OSPF membership. All right. So we have a neighbor for router 2. Let's see if router 1 will come up too. So we only have the one neighbor. Let's find out why it's not working. So no passive gig 01. That's gig 01. And I'm advertising the IP address on it right here. And it's 006. Let's make sure I'm doing the same thing on this side. So I have gig00, but I'm not advertising the network. So I need to add that in there. Now let's see what happens. Nope, and there it goes. Alright, so from this router right here, I should be able to ping these computers. And of course, from these computers, I should be able to ping anything. So let's just find out. Show IP route. Let's see here, I have my 10s, I have my 20s. That's awesome. Looks like I have two different networks. I have a 10.1 network in there. Let's find out where that's at, make sure there's no conflict. Oh, there you are right here. Let's change loopback 5. Let's change you to be 172.16.40.1. Oops, and I almost forgot. Router OSPF 10, no network. 10.0. There's 0. And add a network command. There we go. And now let's see what happens. Everything's looking good. I should be able to ping 172.16.10.50. I should be able to ping 172.16.20.50. All right. So 10.50 came across, hit the multi-layer switch, and came down. 20.50 came all the way across through the layer 3 switch to router 2, then back on a layer 2 path all the way down to HR. So the multi-layer switch is acting as a router, but also acting as a switch. And the cool thing is, the sales PCs, these two right here, they are on the same network, 10.50 and 10.51. So they are on the same VLAN, but as you can see, there's two different connections. These two switches are not directly connected, but they have a layer 2 path going across because the switch is still just switching the connection. So to summarize, layer 3 switches, they're great. They take the best of both worlds and make it easy for you to do it. So some commands are a little bit different, like setting up a trunk, you have to have the encapsulation command, and the encapsulation command is a little bit different than a subinterface. But the layer 3 switch is so flexible that those little tiny differences are no big deal. I hope you enjoyed the video. Let me know if you have any more questions.